All right, we've gone through about half the chapter, and there's three more things that I want to do in here. First, I want to go over the next 4 or 5, whatever it is, pages, and introduce you to some of the particulars here. Then I'm going to ask that we all, including me, um, download some software onto our machine so we can start working with this stuff so you can actually see what it's going to be looking like. All right, so they show you an example here. Now this thing right here, that's more or less a syntax diagram. And please don't think, oh geez, I'm never going to remember all this stuff. You don't have to. You don't have to memorize everything that's in here. But if I wanted to go through the customers table, if forget this is even here. If I wanted to show everything that was in a customers table, not just their name and their city, but everything that existed in the customers table. Are you with me? Let's say there were 10 fields. Then instead of typing in something like this, I could type in select star from customers. And that would show me literally everything that's in the customers table. Does that make sense? So asterisk, for lack of better words, is a shortcut for everything. Now, what if there's a lot of fields in there that I don't need? Well, then I don't want to use the asterisk. Using the asterisk can very much so slow down processing. All right. So in here, notice they didn't do a very good job of this because as long as they do put in everybody's name as last name, comma, first name, I guess it's okay to put it in as one field. That said, that's never recommended today, ever. I don't know why they use this example like this. I would have had a first name field and a last name field. That's the way we're going to do it. All right. And the only reason I'm telling you that is what if somebody comes in and puts in there for like, you get to my name. Geez, I don't know what the guy's name is. Let's just put in Jeff, comma, Scott. Now it's wrong. All right. Or what if they, like this, they've got McMillan, comma, G. What if they put in the next one, if they put in G, comma, Seaver? It's too easy to screw something up when you take and concatenate two fields together when they really should be broken apart. But I want to show you the syntax. Quite often what you're going to see, and this is the way I usually write it, the program doesn't work any better with what I'm about to show you, but I like to do this. You don't have to. I would have rewritten this query that you see right here like this. So what's the difference? Well, you can see looking at it. All of the keywords, all of the SQL keywords, I capitalize. And I'm just warning you of that right now. You don't have to do that. Not only that, with virtually every relational database management system that I know, and I know 3 or 4 of them, this can be an uppercase or lowercase when you're checking, like here they're checking for Washington. Even though in the database it might be in as a capital W, capital A, you can still check for it lowercase. But the keywords here you can see because they're all the ones on the left. Select is a keyword, from is a keyword, where is a keyword, order by are keywords. So I put those in uppercase. You don't have to do that. So this says, what I want you to do is to go out to the customers table and grab me the name of every customer that's in there and their city, but only where their state, not stat, where their state was Washington. And then I want you to order it alphabetically by name. Does that make sense? When you order something in ascending order, you can do this like they show here, which is totally fine, or you can actually put in here ASC. But since that's the default, most people don't use it. But you can, all right? If we wanted it in descending order, we put in DESC. Does that make sense? All right. That you would have to put in if you wanted it in descending order. Not only that, what if I wanted it, let's say I wanted it in ascending order, so I'm just going to I'm going to remove this. I'm going to put a line through here for now. Let's pretend we wanted to do it in descending order by the city. All right, so when you look in here, Seattle, let's say, is last. So we'd have these two Seattle people, but then we want the name in ascending order. You with me? So we've got two different sorts. So we could say city, comma, name, and if we wanted it for some reason to be descending, we can do that. So you can sort on as many fields as you want to sort on, but they've got to go from a major to a minor order. All right. Also, when you notice, if you look in here at their query, and again, there's absolutely nothing wrong with the way they wrote the query. There's nothing wrong with the query. That said, notice what we're doing. We're asking for all customers from Washington. Would you agree with that? Everybody agree with that? But are we showing Washington in here? We're not. So you can grab stuff from a field and then not show the field. I mean, it probably would have been a little repetitive here to say select name, comma, city, comma, state, because this would have then just said WA, 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 all the way down. You could have done it. There would have been absolutely nothing wrong with doing it, but you know that they're all Washington anyway. It's just a waste of time, basically, doing that, but you could do it. It's not that it's wrong to do it in that, you're going to make an error, but it's wrong to do it in that it's, I don't know, there really is no reason. What is the word? Superfluous? All right. There's really no reason to do it. Now that's a simple select. And again, I've used these words. I've used CRUD. All right. And CRUD is create, read, update, and delete. All right. The book will use select, insert, update, and delete. Now, why am I wasting your time telling you this? Because whether you use CRUD or whether you use it the other way, these are what are known as data manipulation language, or DML commands. You use those to actually manipulate the data. You use those 4 commands. And for us, it will be select, insert, update, and delete. Sometimes you don't want to work on the data. You want to take and change what's called the schema. That's the names of the fields, the data type of the fields. Maybe we've decided with the number of units, we're going to start letting people buy half a unit if they want to do that. So it's always been an int, but we want to change it to a double. Does that make sense to people? All right. So there are 3 more commands that you're going to see, and those are, what is it? They are called data definition language commands. All right, and they're also called DDL. And they are, can't think of what the C is for some reason right now, but they're CAD. This is drop. This is alter. All right, like I said, for some reason, it's just, I can't think of what that is right now. All right, but the point is, that's if you want to work with the schema. All right, so you can use those as well. So we're going to be working with DDL, and we're going to be working with DML in here, just so you're aware of that. All right.
Is there a way you can add more like wheres?
Yes, the question is, can you add more wheres? Well, remember how we do this? What does that mean?
I mean, and
What does this mean?
or.
Well, it's even easier in here because we use this and we use that. All right. It's SQL was designed to be a very English-like language, not designed to be a programming language. And again, it was designed by a gentleman who was a mathematician not a computer programmer. All right. Mentioned the asterisk to you already. Okay, now, when you want to combine information from two different tables, this is how you do it. So I'm going to show you this. All right, going by the example that we had before. So again, I'm going to put in here first name, last name. We're going to keep it real simple, okay? First name, last name, no address, city, state, zip. We're going to put in here department ID, okay? Just those three fields. You with me? And here I'm going to put in department ID and department name, okay? So for instance, in this table, you'd have something like Jeff, Scott, let's say 3, and in this table you'd have something like 3, AWD, or 3, etc., something like that. So the boss comes by and says, hey, I need you to create a report for me with everyone's first name, last name, and department name. Now, if all the boss asks for is the ID, I can just grab the information from one table. I could do a select star from that table. So let's say that these are called names, and these are called departments. All right. So if all they want is that, I can do that, but they don't want that. So what I have to do is say something like this, and I'm going to write it out not exactly the way they did it. So you'd say select. In fact, let's do it first the way they do. So I'm going to say here select FN, and I'm going to totally qualify it. Select names dot FN, comma, names dot LN, comma, deps dot DN from names, comma, departments, inner join. All right. And what field are we inner joining? Well, we're inner joining the department ID field. DID, all right, on names dot DID equals deps dot DID. All right, take a second to swallow that one. All right, I mean, it's not as hard as it looks. All it's saying is map up what's in here with what's in here. And when you find a match, give me that person's first name, last name, and department name. That's all we're saying. All right. Now, there are other ways of doing this. I think rather than introduce those to you right now, I'm just going to leave it at that. All right. There's ways to make this easier, and we're going to go through all those as we go on in here. All right. I'm more concerned with at least that you've seen this. Again, it may not make a whole heck of a lot of sense to you. When we start to actually come in and create our own programs, all right, that's typically when the light bulb goes on for people and they're like, oh, that's what you meant. All right. And question just got asked there by Mr. Breeding as far as, can you have more than one thing in a where? Yeah. Not only that, you can join as many tables as you want. The database that we're going to be working with, I think, has got 9 tables in it. We're probably only going to be working with about 6 or 7 of them, but there might come a time when we need to join all of those tables to get the information that indeed we want. All right, so they're showing here again, this is the syntax for a select. It's the word select, followed by either an asterisk or one or more different column names, from, followed by either one or more table names, or what's called a view, which we may or may not even get into, where, if we've got criteria, and order by if we want to do sorting. So again, ideally, you can look at this example here on page 543, and at least conceptually, it can make some sense to you. All right, so we're saying here, what do we want? We want you to go out to the invoice line items table and find for us the invoice ID and the product code. We want you to go out for us to the products table and find the description. Then go back again to the invoice line items table and find us the unit price and the quantity. And I only want you to do this on products, all right, where the product code in the table matches. So I'm grabbing this information from two different tables, all right, as opposed to putting everything in one table. So as it says here, a join lets you combine data from two or more tables into a single result set. There's a lot more joins than what we've already looked at. This is called a simple join, or it's called an inner join. It's also called an equijoin, because we use that equal sign right here, right there. Guess what? You don't have to use an equal sign. You can use a greater than or equal to, an equal to, a less than or equal to, or a not equal to. But the equijoin is the one that's probably done well over 90% of the time. Okay. All right, so how to add, update, and delete data. So this is right now we've looked at the R in CRUD. This is the C, the U, and the D. So here's an insert. Insert into the name of the table, then the field names in parentheses, then the word values, and in parentheses, CS15 is the product code, Murox C# 2015 is the description, 5650 is the unit price, and 3000 is the on-hand quantity. All right. And for those of you, who might turn around and say, I get it. It sort of makes sense. Do we really even have to learn this stuff? Let me just tell you, the average salary for a good database person typically starts at 150 grand a year. And I am not exaggerating. In fact, if you know what you're doing and you become what's called a DBA or a database administrator, those people typically are making $250,000 a year or more. The bigger the company, the more money they're making. But you don't step out of a 2-year school or a 4-year school, for that matter, and get a job as a DBA. You typically have to prove yourself first. And not only that, if you look at a company like Amazon, they don't have one DBA. They probably got a department of DBAs. All right. At a small company, you might be everything. You might be the database programmer. You might be the database administrator. All right. So here's an update. Update followed by the name of the table you want to update. Set followed by what you want to change, the unit price to 54. Where product code equals MCCP. Please look on the screen. See this thing in blue? See this? What do you think happens if I leave that off? Anybody want to guess? It updates every product, now costs $54. Virtually 100% of the time when you are doing an update or you are doing a delete, you put a where in there. All right. And again, I mean, think about it this way. What if instead what we wanted to do here was we wanted to update employees and we wanted to set salary equal to salary times 1.1, like a 10% raise, where department equals accounting. So we want to give all of our accounting people a 10% raise. If we leave that where off of there, now everybody just got a 10% raise. There's a pretty good chance that people aren't going to call you up and say, hey, you just gave me a 10% raise. Did you mean to do that? All right. In much the same way, there's a delete. Delete from customers where customer ID equals 558. And again, if you remove this, it deletes every record from the customer's table. Now, here's a big thing. If you notice, and that's why I left this up here. Here, this D means delete. This D means drop. If you run a delete command and you delete every record, the table is still there. The schema is there so you can rebuild the table. When you drop, it's gone. All right? It may not sound like a big thing, but it is a big thing. Not only that, what a lot of companies end up doing is before they do anything, before they do any inserts, any updates, any deletes, they back up their database. All right, wouldn't be surprised if Amazon backs up their database maybe even once a minute. When you think of the millions of people who are buying things on there right now, they're doing it to protect themselves, all right, and they're doing it to protect their data. Years ago, there was a company that was near the school I used to work at. They were called Lab Safety, and literally they sold safety products to different companies, and they were a multi-million-dollar company. Okay, and I got to know the guy who ran their IT department because he was on our advisory committee. Okay, real nice guy. And I asked once, I said, can I bring the students in? It was only 10 minutes from the campus, so we'll drive ourselves. Can we park here, and can you give us a tour? So he did, and it was pretty neat because it was this humongous warehouse that was really, really, really tall. For a one-story building, it was probably the tallest one-story building I'd ever seen. I don't know how many feet high it was, but very big. All right. And he got done. He did a terrific job. He explained everything, and when he got done, he said, "Are there any questions?" And a couple students had questions. And I said, "I got one." And I said, "How long?" I said, "If tomorrow somebody broke into your system and removed everything from your database, how long could you guys survive?" He's like, "Wow." He said, "I hope you're not taking that as a challenge or anything like that. Like you're." I said, "No." I said, "I'm just curious." Because I said, we've been talking a little bit about security and data, and I just was curious. And he said, 2 weeks. That was about halfway into the tour. At the end of the tour, he said, "I want to correct something I said before, no more than 2 days." He said, "We literally would go bankrupt." He said, "We have millions of dollars that are changing hands every day electronically. And if we didn't have that capability anymore, we didn't know what people owed us, so we just wouldn't be able to survive." All right. And I've called this before. I've called it the Mack truck syndrome, rather. It's like if I'm leaving here today and I get hit and run over by an 18-wheeler, they probably won't have class Monday, but it might even be a week, but they'll end up having class again. I'm not irreplaceable. Right? Data is irreplaceable. All right. And that's why the more important your data, the better the backup plan for that data you have to have. All right. So you use the update, the insert, the update, and the delete to maintain the database data in your tables. Insert again for adding one or more rows. All right, there's ways that you can add more than one record at a time. We're not going to get into that right now, but you can do that. The update and delete, pretty much what you think. All right, so let's just jump into this. Now, notice what they say here. An introduction to ADO.net. Here's a little warning for you. As we get into this and we start writing some ADO.net, you're going to go, "I hate this stuff." I'm just telling you. Because it's not that you got to remember all this stuff, because there's just maybe a half dozen things, but you do have to put them in if you want your stuff to work. All right. Also, you're used to dragging out, agree or disagree. You're used to going and clicking on a button, dragging it out there, boom, you got a button on your form, right? Text box, label, group box, you've done all that stuff. When you put these ADO.net controls, they're called invisible controls because they show at the bottom underneath your form itself. They're not physically on the screen. Now, there's a couple that will be. There's one called a data grid that looks pretty much like a spreadsheet, and that will, but most of the controls you won't even see. And the ADO.net controls you won't see. Now, many, many years ago, when I taught this stuff, and before we were teaching C#, we were teaching VisualBasic.net. And when we taught VisualBasic.net and we came in here, I just want to show you this. So I'll just bring up a project. It doesn't matter what I bring up. All right, and when you brought this stuff up right here, see that, how nice that is? And you've got it where you've got it like in nice little sections, etc. That's not the way it used to be. you literally had a little icon for each one of those controls. That's what went in here. That's how you chose them. Okay? Why? Who cares? Well, they were called at the time ActiveX controls. And you got about maybe between 1 and 2 dozen of them that were here. You could go in and you could add about 50 or 60 more, but you had to literally go in and manually add them to here so you could put them in here. That's the way that it worked. Why am I telling you that? Because the name ActiveX, which is what that stood for, that's the ADO in what we're talking about right now. That's ActiveX data objects. So over time, the way this is done has changed quite a bit, but some of the terminology has persisted over time. All right. All right, as it says, ADO.NET provides classes that you use as you develop database applications with C#. All right. It says these can be provided into 2 categories: the data providers, which provide the classes that let you access the data in the database, and the data sets, which allow you to store and work with data in your applications. When we start working on this stuff, because again, this has happened many, many times, I'm going to show you how literally you can create an application and you can show an entire table from a database. Well, who cares? Well, the kind of neat thing about it, you don't have to write a single line of code, not one. So when people start seeing that, they're like, hey, this ain't bad. Well, that's fine. But guess what? You're like, okay, now I want to go in and I want to be able to make changes to this code. Then you're going to have to start writing your own code. All right. So notice here it says the .NET data providers. And it says a .NET data provider is a set of classes that basically allow you to manage the database. All right, so that's what we're getting into right now, is we're starting to talk about the .NET providers. So let's look at these. All right. The first one that's shown there is, it says connection. And as you might guess, that allows you to establish a connection to the database. All right, you can connect to it. All right, not only that, once you connect to it, that just means that you're able to do things to it. But you can't do things to it until you open that connection. And when you're done, you typically close the connection. So these are just simple things, but they're things that you've got to understand. We are going to write our own commands. We are going to write our own insert statements, our own select statements, our own update statements, our own delete statements. You typically write those and you put them into a string variable, and then you run that string variable because it becomes an SQL command object. If that doesn't make sense, we'll see it in action soon. All right. Then you've got a couple more things in here. Let's not do them in order. The data adapter. Anytime you see adapter in here, basically what it's saying is 2 things that don't work naturally together. The adapter is the go-between so they can work together. So here, the data adapter provides the link between these string commands that you write and the database. All right. And I've used this example with you before, so bear with me for a second, but I think you've all heard this. And that is that if I go into a bank and I talk to a bank teller, they can give me a certain amount of information, but if I ask for stuff that they don't have access to, they tell me to see a personal banker. You with me? All right. Well, in much the same way, sometimes the only thing that you want to provide people with is the data. You don't want to let them change the data. They can look at it, but they can't change it. If you want to provide them that capability, one way you can do that is by using what's called a data reader. And a data reader is known as a fire hose. What the heck does that mean? That means it's like when you got the firemen come in there and they hook up their hose, the stuff just squirts out, right? That's pretty much what happens to the data. And it's read-only, and it's in a forward direction. So if I'm on record 6, I can't go back to records 1 to 5. It's just a read-only way of looking at data. That's it. All right. So some of the data providers. You'll notice in here SQL Server. Well, that's the one you'd want to use if you could. Here's a real surprise. Microsoft makes it easy to work with Microsoft databases and harder to work with non-Microsoft databases. All right. Now, if you look in there, there's OLEDB. OLE is the older way of doing things, and it stands for Object Linking and Embedding. All right. Then there's ODBC. ODBC is a way typically that you create and you link to non-SQL Server or non-Microsoft databases. ODBC rather stands for Open Database Connectivity. Almost always when you see DB, it means database. So you know that. All right, so what are we going to end up using in here? We're going to end up using connections, commands, data readers, and data adapters. So you'll notice the difference between these is how we're connecting. If it's an SQL Server connection, they all start with SQL. If we're connecting through object linking and embedding it starts with OLEDB. If it's Open Database Connectivity, it starts with ODBC. Those aren't my rules. Those are just the rules of the API. So they're the rules we have to play by. All right. This will involve putting in a new using statement at the top. As you've seen before, if you don't put it in, that little light bulb is going to come up saying, I don't know what the heck you're talking about. Do you want to add this using statement? You say yes, and boom, it'll add it for you. So as they mention here, the .NET data providers provide these different ADO.NET classes with the ability to work directly with the database. All right. To use one of these, it says you should add a using directive. We already mentioned that. Notice again, other .NET providers are available to provide efficient access to non-Microsoft databases like MySQL. All right. And it says there, although the .NET provider includes a data provider for Oracle, it has been deprecated and Microsoft recommends that you use a third-party provider. What does that mean? That means that the biggest competition to Microsoft is Oracle. So they want to make it as hard to work directly with Oracle as possible. I'm going to tell you a name you may or may not have ever heard of before, and that name is Larry Ellison. Larry Ellison runs Oracle. He's right up there with Warren Buffett, with Bill Gates, as far as being the richest people in the world. Years ago, one of the things that Oracle did was they bought MySQL. So not only do they own Oracle, but they own MySQL. They are the direct competition, in my opinion, to Microsoft and SQL Server. All right. So how do these different components work together? All right. So here's the picture. So this is all stuff you've got to worry about. You've got a data set. All right. That data set, notice, will send stuff into a data table, which will send stuff into a data adapter. The data adapter will send commands using a connection, and that'll go to the database server. The server, in our case, is just going to be our machine. We're going to use our machine as both the client and the server. But you'll notice that in every one of these, every single one of these, the information flows in both directions. So you can flow into something or flow out of something. All right? But you've got to follow this path. In other words, there's no direct connection between the command and the database server. You see that? It's got to go through the connection. And I can do the other ones with you, but you get the idea. So as it says there, let's just look at this. When you use the .NET data provider objects to retrieve data from a database, you can store the data in something called a data set. All right? The data set contains one or more data tables. What do you mean one or more? Well, did we just look at a join where we grabbed information from two different tables? All right. It says then the application can retrieve and work with the data. In other words, it can do inserts, updates, and deletions. To retrieve the data from the database, the data adapter issues the select statement, and that select statement is put in this command object. Don't worry about remembering this. You won't anyway. But when we write our first application on this, the week you come back, all right, it'll make more sense. And it might be the week after you come back. I don't know. To update the data in the database, it says the data adapter issues an insert, update, or delete in a command object. Then it uses a connection to connect to the database and update the data. All right. Very important term, the second last bullet that you see here on the bottom of 549. It says the data provider remains connected to the database only long enough to update the specified data. You are going to learn good habits in here. What I mean is, technically, if it's your database and you're the only one using it, you never have to close it. Does that make sense? It's your database, and you're the only one using it. It doesn't work like that in real life. It's almost always going to be when you're sharing the database. So you open it, you do what you got to do, you get in, you get out. That's the idea. And that's why it's referred to here as a disconnected data architecture. And that's what they're talking about. All right. And as it says, it offers improved system performance because you're not using system resources any longer than you have to. All right. Concurrency and the disconnected data architecture. Here's the problem. I'm not even going to use their example, but I am going to use their example. And what I mean is this. Let's assume that every single one of us in here, we only have one copy of the database. All right. Now we've all got a bunch of changes that we want to make. Okay, so we each come in and we grab our copies. And now all 7 of us have a copy of the database. We get done. Aaron saves his. Gabriel W. saves his. Gabriel B. saves his. Christopher saves his. Adam saves his. Nicholas saves his. James saves his. He saved last, so he wins. He typically will overwrite everything everybody else has done. That's a problem with concurrency. So how do you get around that kind of problem with concurrency? This is what they're talking about. You can use optimistic concurrency. All right? And it says there, this means the program will check to see if the database row or the record that they need to update has been changed since the user grabbed it. If it's been changed, you don't get to change it because you're not working with the freshest copy. All right? You can also use the worst kind of concurrency, which is that last in wins, which is basically no concurrency at all. All right? And that's what they're talking about. So it says here, how do you avoid that? It says for many applications, this very rarely occurs. But what's important is this. You can do what's called locking on a database. Why does that matter? Because you can lock in different ways. You can lock the entire database, which means if I got it locked, none of the rest of you can touch it if we're sharing it. You can lock it on a table level, which means if I've got the customers table open and I've locked it, none of you can touch the customers table. If we've got other tables, suppliers, distributors, orders, etc., you can do those. You can do it on a record level. So the only thing I've locked is the current record. You can even be as granular as doing it on a field level. All right? So it just depends on how you set it up. All right, it says another way to avoid the concurrency is to design a program so it retrieves and updates the data just one row at a time. That's the best way possibly of doing it because that's the least amount of way that you have to worry about 2 people banging into one another. All right, so believe it or not, we're almost done with the chapter. So how a data set is organized. So the author says in here, this is what they're showing you. It's a little bit difficult to look at, but it should make some sense to you from some of the terminology we used. The data set is virtually, it's your schema. It's everything. All right, it's the whole database. Then it's made up of 1 or more tables. Each one of those tables has columns, in other words, fields. Each one of them has rows, in other words, records. Each one of them has constraints, primary key, foreign key, etc. And probably the different tables are related to one another. That's what they're showing right here. All right. So as it says there, a data set object contains a hierarchy of one or more data table and data relation objects. I'm not going to read to you. You can see the rest of it, but I basically cut it down into kind of a nutshell for you. All right? All right. It says when to work with data without using a data adapter. So when can you get around doing this? All right. So in other words, as it says, when can you access a database directly? So as the author mentions here, if you execute these commands directly, you don't have to use an adapter. That's typically done few and far between. And again, you will see some examples of this stuff. All right. It says, if you use this technique in an application that maintains the data in a database, you typically have to work with a single record at a time, which means your chances of having concurrency problems are going to be minimized. 2 ways to create ADO.NET objects, and this is, next we'll be on the last page. There it is. So looking at this quickly, all right. What we're going to learn, I want you to hear this. What we are going to learn is basically how to build something similar to this right here, but we're not going to automate it. Well, I'll show you how to automate it afterwards. But when we build this, what we're going to have is something that looks similar to this, but in here, we're going to have 4 buttons. And it'll say first record, next record, last record. So this will say something like this. Last record, next record, last record. So why am I showing you that? Because this right here, first record, is like going there and going to 0. This is that one. This is basically, I guess it's this one, is that one. But rather than doing that and using what's the word I'm looking for? There's different things that are set up that'll do it for us. But we're not going to do it like that when we first start. All right? We're going to actually learn how to do it, and so you can see what happens underneath the hood. Right? So why? Because it makes more sense that way to do that. All right. So if you do it like this and just drag a few things out there, it's going to write most of the code for you. You can write a full-fledged database management system without writing any code. Look at this. If I click the plus sign here, it'll allow me to add a new record. If I click the X on a record, it'll remove that record. All right. I can move around to either I guess that was the symbol. First record, previous record, next record, last record. So I can do all that stuff. And you can see these are those things I mentioned that were added down below. See these right here on the picture? All these. All right. Those are your different DAO objects that we're going to end up adding. The code will be written. This is the code, but it'll be written for you. All right. I'm not going to read that to you, as you can take a look at it if you have a desire. All right. So that's it for the chapter. So give me a second here.